types of reactions. 6 main types of reactions which we explore. One is called combination or synthesis. One is called decomposition, combustion, right? So we did that prac on combustion last week. Reactions of acids, displacement that's split into what's called single or double displacement, and lastly, precipitation. So our 2 pracs tomorrow, one is a precipitation prac, one is a displacement prac. So we won't get through the theory before the prac, so I'm going to get you to do the prac and then see if you can make predictions rather than the other way around. Some prior knowledge, right? Things to consider: describing chemical reactions using word and formula equations, balancing chemical equations, right? All that work we were doing last week and while I was away. Prior understanding from even previous parts of chemistry or earlier parts in the course is what's a compound, what's a physical versus a chemical change, and what are our pieces of evidence of a chemical change. So going through those things fairly quickly. Compounds, right? Remember, element is the same type of atom. Compounds is 2 or more different types of atoms that are chemically bonded, right? Can be in either a lattice structure, and we've looked at that, where we've got this regular arrangement, like in ionic compounds, right? Or they can be molecular, like water. They're discrete units. So 2 atoms of hydrogen, 1 atom of oxygen, and I can count them. So I'll pause there. Physical changes when no new substance is formed. So any physical process, melting, boiling, sublimating, cutting it into smaller pieces, crumpling it up, changing its shape. Right? These are all physical changes. So if I take my piece of paper, for example, I've got a piece of paper, I've scrunched it up. It's a physical change. It's still a piece of paper. However, if I take a match to the piece of paper and burn it, I'm actually changing the chemistry of the paper. Yeah, the bonds within the paper break apart to produce carbon dioxide and water, combusting the paper. As an example, if I take a piece of metal, bend it into different shapes or hammer it into different shapes, that's a physical change. If I take a bunch of oxygen or in a blowtorch and start to, say, a piece of iron and it rusts, right? So rust is an example of a chemical change. So new substances are being formed. Mixing, changing shape, dissolving, like sugar in your coffee. Mixing cordial and water, mixing different paints together are all physical changes. No new substances are being formed. And that's the difference between a chemical change. A new substance is formed or produced. Different examples: combustion, burning of something. We did that last week. Cooking an egg, right? It's got a chemical change, changing something about the proteins, which is why the egg whites go from clear to white. Yeah. Rusting of an iron pan, so it goes from that metallic look to browny reddish. Hydrochloric acid and sodium hydroxide, mix those together, you get salt and water. Fruit ripening is a chemical change. Yeah, you've got going from the starches within the fruit are being converted into sugars, which is why it goes from being sort of floury in taste to sweet in taste. So if you get an unripened apple, it tends to be really sour, or it tends to be rather gritty and bitter, right? And so as that ripens, those compounds are converting to sugars. And then when it goes off, those sugars are going off. They're getting oxidized, which is why it goes brown. We're forming acids, and so it starts to taste awful as it rottens and ferments. That's all chemical change. Evidence of a chemical change, they're difficult to reverse. Not impossible, but difficult. New substance is formed. There's a permanent color change. So a mixing of paint, right, although there is a color change, although it'd be difficult to separate into the different colors, it's not impossible. Yeah? So not impossible. We could look on the molecular level and separate it physically into the different pigments. Combustion, burning or exploding. Gas given off, so the rotting of fruit, that stinkiness, right? Small aromatic compounds being produced. Hydrogen gas, when we put a metal in an acid, it bubbles and those hydrogen gases are formed. Sometimes gases are odorless. So we've got to keep that in mind. In fact, the gases in these caps are technically odorless. We put an additive into gas piping for the reason that, for a safety. So if we can smell gas in the room, it's because of that additive. Temperature change. So does heat get given off or does it get cooler? Solid forming, like precipitates. We'll talk about that. Or one metal depositing onto another. Okay, so first example, synthesis. Synthesis or combination is taking two or more things, combining together and forming one thing as the product. So in this example, I've got hydrogen gas, chlorine gas coming together to form hydrogen chloride. Here's another example. If I take a piece of sodium metal and a tube that's filled with chlorine gas, I light or give it some heat, so I need to give it some energy to kickstart the reaction. We call that the activation energy. That's important for the next part of the unit, right? Then sodium and chlorine produces sodium chloride. The products, right, have very different properties to their initial things. So sodium is a very reactive metal. It's got a fairly low boiling point. Chlorine, gas at room temperature, poisonous. Sodium chloride, extremely high melting point. Very stable. It's unreactive. It's non-toxic, right? So when I take two substances, combine them together, the product is a different properties altogether rather than a combination of the properties. Decomposition. So that's the opposite style of process than combination. We take one substance and break it down into smaller substances. Take the example of calcium carbonate. Breaks down into calcium oxide and carbon dioxide. So one substance going too many. My favourite example. My favourite pracs that I'm not allowed to do anymore. It's too unsafe. This is called a touch powder. Highly unstable. It's called nitrogen triiodide. It breaks down violently into nitrogen gas and iodine gas. And it's so violent that iodine is normally a solid at room temperature. But there's enough heat produced in that small amount of substance to vaporize the iodine into a gas, and that's what we see there. It's very loud because of the nitrogen. Here's another example. The rising of cakes is sodium hydrogen carbonate, or sodium bicarb as it's also called. That decomposes to sodium carbonate that's more stable, water and carbon dioxide. And it's that water and carbon dioxide that gets trapped, right, in the starchiness of the flour that causes the cakes to rise.
How does the decomposition start?
This is called thermal decomposition. So what that means is there's enough, when I've got heat, right, the heat is enough to break the covalent, or in this case, the ionic bonds to produce the products, yeah? So it needs some sort of energy or something to kickstart the breaking of bonds. That's what's happening in a chemical reaction. We break bonds within the reactants, and the products are as a result of reforming. So there's a breaking of bonds and a reforming of new bonds. Combustion, as per our prac last week. It uses oxygen. All combustion reactions must have oxygen. You might want to write that down somewhere. Must have oxygen. Two types of combustion. One is called complete. This is when oxygen is in excess. It's like, imagine your blue flame on your Bunsen burner. That is complete combustion. It's clean. Higher amounts of energy produced. Color of the flame is different. Incomplete combustion. Yellow flame. Limited supply of oxygen. It produces carbon monoxide, as an example, or soot. So if I take a beaker, wave it over a yellow flame, we notice that we get black soot on the bottom. And you should have observed that last week with the burning of the methylated spirits. It was a yellow flame. That's indicative of incomplete combustion. There was black depositing onto the bottom of the beaker. Further evidence that it's incomplete combustion occurring. That's what I was talking about. Bunsen burner colour indicates how much oxygen is present in the reaction of burning methane. So methane's the gas that's in here. Yeah. Burning that gives us carbon dioxide and water. As we increase the amount of oxygen, we see the change in flame colour. Finish.